Welcome back to our series on the environmental consequences of engineering design. In this session, we will continue to use electronics and electronic devices to understand the range of environmental consequences on plants, animals, and people posed by the continued design, production, and proliferation of electronics. In this session, we address the recycling process that occurs when electronics reach the end of their useful life. Prior to this session, we have looked at the other stages of the life cycle of electronics and products, from the extraction of natural resources to the manufacture of those products, to their transport for consumption, and to their use in modern society. In the previous session on disposal, we took a close look at the magnitude and toxicity of the electronic waste stream around the world. In this session, we go one step further, looking more deeply into the world of electronics at the grave, as a large proportion of electronic products are sent to recycling, both well-regulated or formal recycling centers in the developed world, and less well-regulated or informal facilities in developing communities. In the United States, electronic waste follows a rather convoluted route before it finally reaches the grave, via recycling or via dumping. Let's take a look at what happens to our electronic waste. When a consumer purchases a product, it gets used for a while, a period of time called the initial use. After that period, the original buyer often gives the product to another individual for a period of domestic reuse. Or the electronic product may go into storage, under a desk, in a closet, or in a garage. Electronics can alternate between domestic reuse and storage for several years before they are finally transferred to a processing center. At this point, working electronics may be reused again, or they may be declared obsolete and prepared for domestic disposal. Legally at this stage, only complete working units can be shipped overseas. Shipping electronic or other hazardous waste overseas is a violation of the Basel Convention. Once overseas, however, these working units, not surprisingly, eventually stop working and are likely to end up in dumped or informally recycled facilities, with insufficient regulatory oversight to protect both environment and public health. If, however, the electronics are disposed of domestically via official processing centers, they usually end up in well-regulated recycling facilities, which pose minimal harm to plants, animals, and people. In these formal recycling facilities, many different sorting and processing steps are needed to sort through the very heterogeneous stuff that is electronic waste. At the very beginning of these recycling processes, waste is divided into what must be manually disassembled and what can be sorted automatically. In general, toner, glass, batteries, and certain other materials are separated from electronic devices and appliances and manually disassembled to recover copper and other metals of value, to recycle certain plastics and batteries, and separate other materials that can be reused from what must be disposed of. The automated process is similar, except that the devices, assemblies, and appliances that go into the automated process are first shredded to make the waste smaller, and then processed by hand or machine to separate non-ferrous and ferrous metals, copper, and other materials for reuse from the remainder of the waste. When done properly, this approach to recycling, reusing, and disposing of electronic waste is relatively safe to both workers and environment. However, when recycling ends up in communities and facilities that are not as well regulated, serious effects on environment and human health can emerge. Despite the Basel Convention, massive volumes of electronic waste still land in developing countries in informal recycling facilities, such as the well-publicized facilities in Guangzhou, China. And when they do, recycling practices lead to not only a range of public health crises, but decimated local ecosystems and environment as well. informal recycling facilities follow similar practices to formal recycling facilities, but do so in a way that puts both environment and public health at risk. As with recycling in any product, some of that product is useful for reuse and some is not. Many metals and electronics, such as gold, copper, silver, and platinum, are sufficiently valuable that they are worth extracting from electronics. Copper, for example, is typically used in cables, and cables are often burned to remove the insulation around the copper and release the copper for reuse. Many electronics are also burned once they are divested of anything of value to reduce dumping volume. Whether burned or illegally dumped, however, without proper controls, this part of the electronic waste stream can wreak havoc on the environment. For other metals, burning is not effective. For instance, gold can be extracted from waste electronics by leaching, thereby recovering the gold and leaving liquid waste and the remaining electronics behind. And finally, electronics, whether formally or informally recycled, are often shredded and dismantled to separate electronic materials worth recycling from those that are eventually dumped. All of these processes rely on careful regulation and control to be safe, and without such controls can easily set the surrounding environment awry. For example, let's take a greater look at burning. Burning releases both harmful fumes and ashes and particles into the air, which, depending on their size, can travel hundreds and sometimes thousands of miles to impact the health and environment of communities far away from informal recycling facilities. The stuff from burning that lands back on the ground and sinks into the soil can cause additional problems with crops that grow in the soil as well as underlying groundwater tables. Particles and toxins released by burning have high potential to travel long distances and all the way up the food chain to have impacts on both environment and public health that range far away and long into the future. Uncontrolled dumping has similar effects to burning, but these impacts are more localized. Most regulated landfills in developed countries, in particular, have liners that prevent anything dumped there from leaking or leaching into the underlying soil and groundwater. Uncontrolled dumping does not have such safeguards and can not only contaminate underlying soil and groundwater, but also releases fumes and particles into the air that have impacts similar to burning. Shredding and dismantling also has similar effects to burning, and like uncontrolled dumping, these effects tend to be more localized. Shredding releases fine particles, which in addition to traveling long distances, can also produce byproducts, which in turn leach into the soil and produce even greater quantities of fine particles. Fine particles are a serious health issue to living and breathing beings. Not only do fine particles travel well and travel wide, they also bypass the body's defense systems in the nose and upper respiratory tract. In so doing, they can infiltrate the body through the lungs and can cause a wide range of systemic difficulties and diseases that are hard to trace back to the inhalation of these fine particles. Whereas fine particles are insidious in air, leachates are insidious in water. Leaching uses liquids to extract precious metals from electronic waste such as gold and silver. The resulting liquid waste, if not properly handled, as is often the case in informal recycling centers, flows into surrounding waterways, spreading the contamination for miles around and bioaccumulating up the food chain. Furthermore, two of the most common contaminants in leaching waste are cyanide and hydrochloric salts, which are acidic and can decrease pH in waterways, leading to massive die-offs among fish and other living organisms. These die-offs can have drastic and rippling effects on the food supply and the ability of higher-level animals to survive around acidified waters. The good news is that engineers and others associated with product design have many options to reduce these environmental consequences. One of the most accessible and available solutions to the professional engineer in the U.S. workplace to reducing these effects is to use RoHS certified components and parts. RoHS is a European directive that requires certain of the most toxic substances in electronics be eliminated altogether or reduced to minimal levels. The most common toxins prohibited by RoHS are the heavy metals, lead, mercury, cadmium, and chromium, all of which have serious impacts on animal and human life, particularly children. But RoHS goes well beyond heavy metals and prohibits a variety of other organic chemicals from being introduced to electronics as well. The absence of these chemicals once electronics are at the grave and shredded or burned in formal or informal recycling processes makes a major difference in the overall environmental consequences of RoHS certified electronics versus those that are not certified. Simply choosing RoHS parts over uncertified parts can make a big difference. Engineers and others involved in the actual design of products containing electronics also have a golden opportunity to reduce the ugly impacts of electronic waste by choosing modular rather than tightly integrated throwaway designs. Modular smartphones, for example, have been on the horizon for many years, and bringing them into the mainstream can make a dent in the millions and millions of cell phones thrown away in the US alone each year. Designing products for easier service and maintenance can have the same impact as an explicitly modular design. Too often, a consumer throws away a computer because it is easier to buy a new one than to fix an old one. Redirecting this habit back to a mindset of repair rather than replace requires the engineer to get involved from the very start of project design. And finally, if an engineer or product designer feels particularly brave, it is possible to turn away from planned obsolescence and design a product to do, of all things, last a long time. It's been done before by engineers for KitchenAid mixers, for some laptop computers, for toasters, and for alarm clocks, and it can be done again with sufficient willpower and some corporate blessing within a capable design team. While there is no doubt that electronic waste has a disproportionate and negative impact on the environment compared to other forms of waste, all hope is not lost. Engineers have multiple opportunities to design products for a better fate at the grave. Whether through purchasing less toxic components or adjusting the design for less impact during disposal and recycling, engineers can make a difference in the ultimate environmental consequences of disposing of products and electronics. This concludes our second session on the disposal phase of electronics, components, devices, and appliances. Thank you for joining us today. We certainly hope that we've convinced you that e-waste can and should be managed more responsibly, and that you'll join us again to look at other phases of the life cycle of products and electronics.